Recording. All right, so I'm setting the test for just that Monday before Thanksgiving. So in finishing Unit 7 this week. Today's the lab for Unit 7, then next week we will do Unit 8. Then we will do Unit 9, which will not be on the test. And then we'll have the test just before Thanksgiving. Okay, so the units are 5, 6, 7, and 8. So we haven't seen 8 yet. And I think that's when we start semiconductors. And what else? So to be eligible for full credit, the labs 5 through 8 and homeworks 5 through 8, which are the chapter summaries, chapters 5 through 8 are due by November 22, by just before midnight. What else? Anything else I want to say at this point? If you want feedback from me, then you must get the labs in sooner than that. I can't sort of, if you turn something in Sunday and want feedback by Monday, that's not happening. Okay. And of course, ask questions. So you should be finishing labs 5 and 6. I've gotten a few 5s. I think I may even have a 6 in my email somewhere, but I haven't probably graded yet. Are there questions? 5, 6, anybody start to look at 7 and have a question?
For that 5, that again, when you say insert like a overflow indicator.
Overflow indicator for the signed. For the signed or the unsigned?
For the unsigned.
The unsigned. Okay. So the overflow indicator. All right. So let me find that lab so we can point to that must be here, part B. Download it. And then you feed with okay. So I asked, so we have some range of numbers. We're dealing with 4-bit numbers. And for 4-bit numbers, there is 2 to the 4th or 16 possibilities. And since we're saying we're building an adder subtractor by including subtraction as an operation, that sort of implies that we're also dealing with negative numbers. So we're going to be dealing with signed numbers, numbers which have a sign. And if we have 15 of them, then we go from -8 to +7. So we're going from -8 to +7. Okay. And then subtraction is just the addition of a negative number. So we're going to focus on addition, because subtraction is just a form of addition after you negate a number. So then we're going to ask, an overflow is when some operation on numbers that are in your range take you to numbers that aren't in your range. So if I add, and there are 2 ways for that to happen here. I can add 2 positive numbers and get something bigger than 7. That's taking me outside of my range. Or I can add 2 negative numbers and get something less than -8. That's taking me outside of my range. The overflow, it takes me outside of my range. All right. All right, so if I'm adding, and here you're supposed to supply examples. So one possibility is what? Overflow takes me outside my range. I want to add two positives and get something more than 7. So 4 plus 5 equals 9 will take me outside of my range. 9's not in my range. And another possibility on the other side, an example of the other thing, to be, we can do, I don't know, let's do just -4 and -5 is -9. That also takes me outside of my range. Okay. So let's write them down. So 0, 1, 0, 0, that's 4. That's +4. And 1, 0, 1, that's 5. And if I add them, I get 1. Nothing wrong. 0, 0, 1. And there was, if you want a carry, if I want to fill in the carries, that's what this is for. Let me make them a different color. How about green? So there was no carry here and no carry here and no carry here, but 1 carry here and no carry here. Okay. So those were here are the numbers I'm adding, here were the carries. And now I have to find -4 and -5, so I will cheat. Always cheat when you can. So here's my calculator, here's my programmer mode, put in 4 negative, it's 1100. That's the carry. 1100 is -4. -5 is 1011. We know they're negative. 1011. We know they're negatives because they start with 1s, and that's our signal that a number is negative. It's only 4 bits, and so that first bit is a 1. Those are negative numbers. And if we were to add these, we would get 1, 1, 1, 0, and 1, and the carries were, I wanted them to be green. Not everything green, top row green. And there was no carry, and no carry, and no carry, and a carry. Okay, so that is my 2 examples of something overflowing, of my operation taking me outside of my range. And now we want to build some circuitry that finds that would indicate that. And I'll show what I think, to my mind, is the sort of direct approach, and then there's another approach that's a little slicker. Okay, so what I do is I look at this column and say, I know a problem occurred if I add 2 negative numbers and get a positive. I know a problem, should have been a 0. I know a problem occurred if I add 2 positives and get a negative. I know a problem occurred if I add 2 negatives and get a positive. That's clearly a problem. And so what I will do it right here below. What I will typically do is insert a table with, that'll get me started. Here is A, B, and the sum. That's this, this, and this in the most significant. So the most significant digit, the sort of, can't really call it the 8th place now because it's we're dealing with sign numbers. But the most significant digit for A, B, and the sum. And I just do my usual 1, 2, 3, 4, 5, 6, 7. I need one more. Come on. Insert row below. Okay, so I start with my all my possibilities. I'm just making a truth table. Zero, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1. So I'm just making some truth table. That's not the sum, but the sum. Okay. Most significant, most significant, most significant. And then I want my, you know, my indicator of bad indicator. Well, who was bad? When I added 2 positives and got a negative, that was bad. We'll say true for that. And when I added 2 positives and got a negative, that was bad. And everybody else is good. And then I can build this circuitry. I'm going to just sort of sketch it. We know that this is not A, not B, and the sum. And we know that this is A and B and not the sum. So if we were doing that, let me get a way of doing this. Snip. So okay, so I have some region to draw. I have my last adder. Here's a full adder. There's A, B, and the carry in. And here is the sum going out and the carry out. And there's some excluded OR into the B. That's about negating the number. And I'm not interested in that. I'm interested in the action of the addition. So there's something coming into A, there's something coming into B, there's something coming into C from the thing above. There's something going out here. There's something going out here. There's something coming in there. Okay. And what I did in my approach, not that, but the other Word document, is I have a truth table for when it's bad based on A, B, and the sum of the most significant. So this is the adder in that position. And I sort of pull down from A. Let me change colors or whatever. So I pull down from A, but I also make a not A. I pull down from B, and the other thing's much slicker. So my way is like tedious, but there's a not B. And then there's this sum and the not sum. And then it was not A, not B, and that's terrible. You can yell at me. Oh no, that's an and. Later it's the or. So A, not B, and the sum, and the other possibility was A and B and not the sum. And those are the 2 possibilities for overflow, or indicating that it was bad.
And then you would just put like some kind of probe
And then, yeah, put a probe there.
to light up with it.
So that is like my, like, you know, not too smart approach. Like I'll call it the straightforward approach. We know it's sort of logically easy to understand. If I add 2 positives, get a negative, or if I add 2 negatives, get a positive, that's bad. Here's the signature of that. A and B, if A and B are 0 and the sum was positive, that's the signature of bad. And if A and B were 1 and the sum turns out to be 0, that's a signature of bad. And either one of those is bad. So the final leave the OR gate. So that's what I call my straightforward approach. What the sort of slicker way that, like, if you Google, you find, or now I'm also telling you, is you can play with these 2 carries. So you can play with the carries, and you can see that both of these bad situations had one of the carry. So there's the carry in, or you can say this guy is the carry in, but he's also the carry out from the previous edition. That's the same thing. So you can look at the last 2 carry outs, and I think it's like an excluded OR. So you can see that one of the bad situations was 0, 1, and the other one was 1, 0. And I think that logic flows through. So that's what, so people who just Google the answer, give me some quick little excluded OR. If you talk to me, then you end up with this monstrosity, but it's easy to understand. At least it's straightforward. It's a monstrosity, but it's an understandable monstrosity.
Can you go over, where's the excluded OR at the P again?
The excluded OR
At the P that you drew.
would be, if I were to do the excluded OR, I would have 2 of these things. This is the most significant. And then this is the next one, the next one going down. And he's got a carry out, and he's got a carry out, and then it's an excluded OR. So that's a lot simpler looking. Remember that an excluded OR hides stuff. So mine's not quite as much a monstrosity compared to this as it seems, because an excluded OR hides a lot of stuff. In terms of circuitry, well, there are only 2 inputs for that. So it's mine has 3. So, but this looks really simple. It's not as simple as it looks. This one I consider to be like straightforward. It's, you can easily explain to yourself. I add 2 positives and get a negative. I add 2 negatives and get a positive. That's clearly bad. Either one, I take. They're both. Don't have to do things my way. I'm not that kind. Any other? Yes. Part B, lab 6. Lab 6, part 7, and it's part B. Okay. So are you asking me to do both these things, one of these things? The top one, okay. So I gave you like a head start, then you build this thing. So let me just explain how this thing operates. Okay. So A, B, C, and D are data. And the D comes to here, which comes to here, which goes to the ones place of the indicator. So so A, B, C, and D are data, and D is the ones place, C the twos place, B the fours place, A the eights place. So if I tell you I want some particular number, I tell you I want, let me go to hex. and clear this out. And let's say I tell you I want a D, then I want 1101. And so you would make it high, high, low, high. And of course, this top thing is the high, the thing connected to the ground is the low. And so I didn't in this one, but often I make the ground like a black color, something like that, to make it clear to me which one's high and which one's low. So that's what, so I give you something I want you to load up, you figure out what it is in binary and prepare the switches. Okay. This thing is a mux. And so it chooses where the data is coming from, and I want the data to come from the switches. If I want to bring in a value from the switches, I want to choose the switches. And so so that yellow line there is connected to the NOT. So I want L to be low. If L is low, I'm loading. If L is high, I'm holding. So this determines whether I'm loading or not. And so when the L is low, then the NOT, after the NOT, that gets a high, and that is the one that's choosing the switch. So if I want to put data in, if I want to load this parallel loading register, I figure out what I want to load, A, B, C, D, A is the 8th place, B the 4, 2, C the 2, D the 1. I put my L on low, and then down here, these flip-flops down here are, and we can tell this a little bit by the this little sort of notch or greater than looking sign, and then it's labeled as a clock. That means that these are edge triggered, so that you must go through an edge for anything to be written to the flip-flop. And so that means you got to sort of go tick-tock back with the T switch here. So if I say load up a D, you'll say high, high, low, high. You put the L on low, and then you'd go back and forth with the T. Only one of those edges matter, but I always go back and forth to set myself up for like the next time to go through another edge. And sometimes you can turn it off and turn it on, and then if things are right, it just happens, but it's better if you just understand how it works. So sometimes you can get that effect of an edge when you sort of turn on the simulation, but you don't want to count on that. You want to understand and force yourself through the edge. Did it work? No?
No.
Then I have to look at your build. You must. It should be L low, go through the clock cycle, compare A, B, C, D. So if that's not working, then I need to look at yours, just to debug it and figure out what we think is connected but isn't connected. Any other questions for the recording? Any other questions for the recording? I'll answer almost any question, do your work for you. If only you ask. But you're not, so I will stop recording.